Now I've decided to use a full-length piano hinge. There is an option to make the hinge pin removable. A different way of doing the hinge pin is to cut it in half, and you do some work in here from inside, and you can make it, you cut the hinge pin in half and you bend each half at a 90-degree angle, and up underneath inside here you reattach it using strips and screws and stuff like that. So basically you can disconnect the linkage for the flap and basically roll it out of the way, and then you can reach up underneath, take those couple of clamps off, and then pull your hinge pins out that way. I didn't use that option. I just have a full length hinge pin. So what they say you need to do is at your aileron hinge location here, you can see where the hinge pin is. You drill a hole in this bracket so that you can disconnect the aileron linkage, move the aileron out of the way, either direction. I don't know if it's this way or if you drop it the other way. But with the hole in this bracket, you can pull the hinge pin out through the bracket this way, which is the option I selected to do. So what I do is, now that I've got the flap in place, I take the hinge pin and I push it up against that bracket. Where is it? That hinge bracket. I just drive the pin into it and rotate a little bit so it leaves a mark, just like I do with when I match drill holes by hand. It leaves a mark, which you're not going to be able to see. Well, hold on, let me get a flashlight. You basically just leave a mark on the bracket using the hinge pin, so that at some point down the road you can drill a hole in that location. So I don't know if you could see that mark. Probably not. But anyway, that's the idea. Just another little tidbit. Alright, moving on. Alright, so I've got my mechanical stop made for the aileron. It is this, let me see if I can point to it. Where are you? It is that piece of white, I don't believe it's nylon, I don't remember what it is. It might be a nylon, but there it is there, that white piece. You can see the ball end, the rod end. Of course, this is the aileron bracket here. What's neat about this is, for now I don't have a nut on, so I just have the bolt that runs through the bracket, through the rod end, through my mechanical stop, and then it goes through the other side of the bracket, but I don't have a nut on it. This mechanical stop also acts as my spacer, and I'll show you a picture of this, the mechanical stop here. So it acts as a spacer, and it's also the mechanical stop. The way that it works is it will bump up against this edge of this bracket. So you can see if I rotate it kind of out of position, I put a flat on it, and I'll explain that in a minute, but if you rotate it like that, you'll see when it comes up to the metal bracket, it will basically readjust itself like that. It rotates so that the flat is actually up against the bracket. I'll do that again. If I rotate this out of the way, when I come up and it meets the bottom of the bracket, I can't get a better shot of that, it will rotate into position. So the flat of the mechanical stop is flat against the bracket. So with it, you can hear it. That's a hard stop. With that in place, and with the aileron fully deflected, I don't have any binding here Now, the clearance between this bracket and the push-pull tube looks very close, and it is close, but it is not hitting. The mechanical stop prevents them from touching, and you can see I still have movement. Now, this rivet head gets trapped underneath here, so you can see how much movement I have here. And when I run this to the stop, I don't have quite as much because the rivet is hitting underneath here. But that's okay, it's not binding, it's still free to roam, and I'm tight up against my mechanical stop. So that I am happy with. Same thing on this end. I still have my freedom of movement, and even when I'm hard against the mechanical stop, it still moves. And I don't have any rubbing through here when I move the aileron through its full travel. Now, what I'm not sure about is this mechanical stop is for the aileron up position. So this is full aileron up. Full aileron down, at the moment I don't have a stop. The only thing that's preventing this from going any further is the physical contact between the push-pull tube and the hole that it goes through right here. I have not come across a mechanical stop for this position. Maybe it's later on in the build process, maybe it's somewhere in the fuselage, I don't know. Because the mechanical stop that I'm using here, that's a modification. That's not what the original plans call for. So maybe the original that's drawn in the plans, maybe that works as both an up and down stop. So I may have to find an alternative for this method to get the full down stop. I'll have to research that, but I'll find something that will work, and of course I'll make a video of it for everybody to see. So next thing that I want to show is the instructions state that you can have a max up deflection of 32 degrees. What I use is a digital scale. This has already been set to 0. How I set to 0 is like we had done before. You come in here with your neutral jig, right? Your neutral jig goes in here like we've had it before. With that in place, and with it seated like I've talked about in my other video, you put your digital scale on the top side of the aileron and set it to 0. And of course you can check your trailing edge with your down at your other end there where you still have your reference line. Check that against the jig that you put in here, but with the jig in place set to 0, your reference line should still be at 0 if you've got your push-pull tube adjusted correctly, just like we talked about earlier. So with that in place, you put your digital scale on the top side of your aileron and you set that to 0. That is 0. That is your neutral, your aileron neutral. And then, I'm going to turn this on. And then you can set your digital scale back on. And I am not going to be able to do this with one hand. Well, hold on, maybe I can. Maybe I can do it this way. It's just losing focus. But you can see that I've got 32, it's upside down, but I've got 32.1, 32.2 degrees of travel. It's all over the place at the moment because I can't hold it on there correctly with one hand and still get a good shot of it in the camera. 32.2 is what I've been getting consistently. So that mechanical stop starts off, where is he? That mechanical stop starts off as a round piece of nylon or whatever material it is. I believe it's nylon. And then you gradually sand a flat into it, make it flatter and flatter, removing material from it. You have to fit it back in here and keep fitting it. It's trial and error, and keep cutting it and cutting it and cutting a flat on it until you can get it to seat and give you that 32 degrees. Okay? So I think I covered everything there, and I'll move on. I wanted to come back out and take a more of an overall view of everything, because I was trying to set the camera up to be focused real tight on some of the things I just talked about. Now I want to take a look a little bit further back. So again, mechanical stop is on this bolt inside here where the rod end is, and you can hear that it's a hard stop. With it on the hard stop, I get 32.2 degrees of travel. When you put your, after you get your zero set point, choose an area on your aileron to put the scale. Shoot, I just set it down. But if you put your digital scale, I use 2 rivets as a reference. So when I put my scale on here to get my zero, I reference these 2 rivets. That's where I took my zero. That's where I take all my measurements. You don't want to take a zero reference here and then do all your measuring down here. Probably doesn't matter. This is such a short distance, and the change in angle, if any, would be minimum. But again, you want to keep everything as precise as you can get it, because in the long run, it's going to pay dividends. So pick an area on the aileron. I like to use the rivets. Put your digital scale on, get your zero set point, deflect your aileron full travel, check your digital reading at the same location on the aileron using your rivets, and then keep sanding a flat on that mechanical stop until you get this to deflect the full 32 degrees. And then when it's fully deflected and hard on the stop, just make sure nothing is rubbing through the hole. You don't have any binding anywhere. You don't have linkages down there rubbing on each other and touching. Okay? Make note when you build your wings, make note what your travel is. If you want to get really precise, I'm using the digital level, so I was getting 32.2 degrees on the digital level. Is the 0.2 that critical? I don't think so. But I want to make note of that because I'm going to compare it to the full travel stop on my other wing, and it should be close to 32.2. You don't want one to be fully deflected at 30 and the other one fully deflected at 32.5. You want to stay at 32, and you want to have them as close to each other as possible. Okay, now I'm going to move on.